Carly, what's a function mean to you? And how has a function impacted your life? You don't even know what a function is? Yeah, no, I didn't expect you to either. All right, so we go through a lot. And it's going to be different. This is a different type of chapter. Gavin, what do you know about domain of a function?
I don't really remember.
You don't really remember? Do you remember the word, though? The word sounds familiar?
A little bit.
A little bit? All right. Jeff, you remember the domain, don't you?
No.
No? Dang. All right. Well, I guess we're needed, Mr. Parker.
Yes, we are.
So, all right. So we're going to, and I don't want. It's just different. It's different. Sometimes it takes a little bit to click. Sometimes it clicks right away. For this, so we're going to talk about domain and range. We're going to talk about what a function is. Some different things here for section 3.1. First thing we got to start out with is what's called a relation. Okay, a relation. Oh, let me see those guys. Okay. In inputs and outputs, input is something you put in. Output is something that you like in a machine you get out. Okay, so raw materials go in, like a product goes out. We do a lot with math with equations. For example, the number of hours you work and the pay you receive form a relation. You work 5 hours, you might get paid $50. So hours is the input, the amount of money you get out is the output. Okay, can you think of other relations? Well, take a second here. In this case here, all right, and just kind of do this on your own. It says, when you buy an item from a vending machine, describe two possible relations identified with the vending machine. Okay, think about each relation. All right, and let's just think about, I don't know if we need to think about two different ones. I think that's overcomplicating it. So basically, you put money in, and what do you get out? You get out food. Okay, you get out food or you get out drink. Okay, so the input, so you could put in $1.25, you could get a protein bar. Or you could put in $1, you would get pretzels. Or we could get juice. If we put in $1, we could get popcorn or water or cereal. So the amount you put in will base upon what you get out. Okay. If I put in $1.50, I get an energy bar or an energy drink. Okay, so the input changes, your output changes. It's not going to be the same. If I put in $1, okay, I can't get the energy bar because it costs extra. Got it? In math, a function is a relation that pairs each input with exactly one output. So typically, here's your input's a number. We put it through the function, we get an output. So I put in -2, 3 times -2 is -6. If I put in 5, I get out 15. So one input determines an output. All right, right there on the right, see where it says determine whether relations or functions? Either star that if you got to highlight or highlight it. This is real important here. We've already talked about a relation. That's just something that creates ordered pairs. When a relation is given as ordered pairs, the x coordinates are the inputs. The y coordinates are the outputs. Okay, right here, this is real important. A relation that pairs each input with exactly one output is a function. Okay? A relation that pairs each input with exactly one output is a function. Now let me go back here for a second to our vending machine. The money is the input. If I put in $1, what can my output be from this vending machine? From the first row, I can get what? Popcorn. That would be my output. If I put in $1, can I get anything else out? I could get Serial. So right here, I got the same input. Do I get two different outputs? That would not be a function. The same input cannot go to two different outputs. Now we're going to be dealing with numbers. Okay, you can only go to exactly one output. All right, so let's take a look at these examples here. Your x's, the first coordinate are your inputs. The second coordinates are your outputs. -2 is an input. It is paired with 2. Is -2 paired with anything else? Okay, we got to make sure that makes sense. Okay, Austin, is -2 paired with anything else?
-1.
Well, here's what I want you to look at. Maybe I didn't explain that real well. -2 is the input. Does it show up as the input in any other?
No.
So then we're good. -2 goes to 2, doesn't go to anything else. -1 goes to 2. Does -1 show up as the input anywhere else? No. 0 is my input. Does it show up anywhere else as the input? No. 1 and 2. Are those inputs all different? That's a good thing. It's okay that these 2's are the same for the outputs. As long as one input goes to exactly one output, we're okay. So here's what you would do. You would say this is a function. Now, a key thing here that throws some of you off says the word explain. Use the definition to explain. Basically, each input goes to exactly one output. Okay, so that would be your explanation. So each input goes with exactly one output. Okay?
Make sure we're writing the explanation down, guys.
Yeah, put this down because this is the hard. Sometimes this is the hard part. All right, when does this not happen? Okay, when is it not a function? All right, you look at that second one. Okay, I will tell you this is not a function. I'll tell you this now. Okay? See if you can tell me why. Okay? All right, I'll get you in a second. Give everybody else a chance to look at it. Everybody take a look at it. See why it's not a function. Maybe our classes got something. Zach, why is this not a function?
Because there's 2 4s as inputs.
Good. There's 2 4s as input. Like highlight these, circle these, whatever you need to do to bring those to attention. If one input goes to a 0, that same input cannot go to a different number. Okay? So it's not a function. The 4 appears twice, or you could say, and I'm going to say the input 4, the input 4 goes to 2 outputs. And another way you can word that or explain it is because we have 4, 0 and 4, 3. So that means it's not a function. If you get one input that goes to 2 different outputs, then not a function. Okay. All right, how about C? Do you have an input that shows up twice with 2 different outputs? Oops. Yeah, 0 goes to 5, and it has to go to 2 different numbers. Sometimes they'll try to trick you and put the same 2 there. They have to be 2 different ones. So this is not a function. Not a function. The input 0 goes to two different outputs. Okay, which is 0.5 and 0.6. All right, is there any other case? Is that the only case that blows this one up? Yeah, that's the only case that blows this one up. So you got 0.5 and 0.6. All right, how about D? Really think about this one. Yeah, I'll give everybody a chance to think about it. I think this one's hard. So, Ava, what do you think?
I think it is a function.
It is a function. It is, because it would not be, these arrows are how you would view this as an ordered pair, even though it's not listed. So you could say that would be like -1, 4. This would be 3, 15. And this would be 11, 15. As long as the X doesn't repeat, as long as the X goes to 1, it can go to the same one. That's okay. So this is a function. This is a function. Each input goes to 1, goes to exactly 1 output. All right, so that's just kind of getting an idea what's going on there. And that's if you're given a list of numbers, a table of numbers, a set of numbers. You're just looking to see, does that X value appear twice? Does that X value go to two different numbers? Now, something that would not be a function is if you had this -1. Whoops. If this -1 also went to 15, like that. Got it? All right, now, vertical line test. Is that something in your memory banks? Is that, I'm just Maya, you've heard that?
Heard it before?
All right, I just want to see if you've heard it before. All right, if you got a graph, okay, this is a really simple test. If you draw a vertical line and it hits every point in the graph only one time, or every part of the graph only one time, then it's a function. It passes the vertical line. So that hits it once here, once here. This is a function. Once it hits it twice, not a function, because, and I'm just making numbers up. This could be, say, the number 3, 4. This ordered pair would have to have an X value of 3, but a different Y value. So the X value appears twice. All right, flip it over. All right, you just got a bunch of dots there at the top. All right, function or not? Gavin, what do you think?
Not.
No. Okay, not a function. Because right here, I can draw this vertical line, and it hits 2 dots. Okay, so not a function. Now, for this case here, since I do have a graph, my explanation just needs to be fails the vertical line test. And I don't care. You can put VLT. Fails the vertical line test. Okay. So the vertical line hits it twice. So you might want to draw that in there just so that you have it. Now, because here's what's going on. The ordered pair for this one here is 5, 1. The ordered pair here is 5, 5. So the 5 appears twice. Okay.
Is there any place where it fails the vertical line test, guys? You guys see that? Does it fail anywhere else?
Right
Yeah, what do we
here.
got? What is that? 2, 2, and 2 what? 5?
Yep. 2, 2, 2, 5. So the 2's appear twice. All right. If you look to the right, does that fail the vertical line test? Okay. Does that fail it? Austin?
No.
Nope. So that is a function. So this is a function. Passes.
Guys, a line is a function all the time except when. Can you guys tell me when a line would not be a function? Anybody think that in their head? When would a line not be a function? There's one case. Well, when a line's what? Go ahead. Vertical line. Nice job.
Yep, that's the only case. If it's perfectly vertical, it automatically fails. But any other type of line, if it goes up, if it goes down, or if it's horizontal, okay, those are all functions. All right, that part C. Okay, all right, hopefully we're good now. Y, is that a function? No. Okay, this is not a function because this fails the vertical line test everywhere. Okay, so not a function. Not a function. Fails the VLT, vertical line test. Okay, so every point there you're going to have two points with the same x value. Okay, just depends on where you put that one. Let me put that one right there. So that's 2, -2, and this looks like it's 2, 8. 2, -2, and 2, 8. All right, now domain and range. Domain and range. Domain of a function, okay, is a set of all input values, which are your x's, the first ones. Range of a function is a set of output values. Okay. So domain and range. So take a look at this first one. All right. What would our domain be? Any ideas? Okay. As you take a look at that first case. Brian, any ideas?
No, I don't know.
All right, let me do something to help everybody. Okay, Zach,
Yes.
what is this ordered pair right here?
Negative. Wait. Oh, -3 and -2.
Okay. Keep going, Zach. What's that ordered pair?
-1 and 0. Or wait, no, 0 and 8. Yeah.
No, you're right. What's this ordered pair?
It is 1 and 2,
And then what's that last ordered pair?
3 and 4.
Okay, the domain is the input. So I'm going to write domain, put a little colon. So do that it's underneath there. You got the domain underneath there. Okay, so those ordered pairs, what are you looking for the domain? Is it the first value or the second value? Ava? First one. Now, we always want to list in order from smallest to biggest. So the first values are your domain. So the domain is going to be -3, -1, 1, and 3. Okay? -3, -1, 1, and 3. All right. Using that, what's the range? The range, it tells me up above. It tells me up above it is the set of all possible what? Outputs, which are the second ones. All right, what are my outputs? Maddie, what are my outputs?
The second number, which would be -2, 0, and then is that 2, 4?
Yep, it'd be -2, 0, 2, and 4. So we're just going to list those. So -2, 0, 2, and 4. That's my range. Okay, that's all the range. Just those 4 values for each of them. Because there's only 4 points, right? There's only 4 points. All right, B. This is the one that worries me. Domain, range. Domain is the input values. Here's what worries me. Do they list individual points? No. Up here, we only had 4 points. How do I figure out the domain here? So this is a point. It has an x and y value. This is a point. This is a point. This is a point. All of these are points. So technically, really, how many points are there?
Infinite.
There's infinite. We can't list them all. All right, how do I list the domain? So think about this. What is the smallest x value that shows up on this graph? The smallest x value. Let's see if we can at least figure it out. Ellie? -2, this right here that would be the point -2, 0. That would be, is there something smaller to the left of it?
That's -1.
Oh, you're right. I'm wrong. Dang.
It's okay, man.
My fault.
We're in
I'm
this
way
together.
off. You're correct, Ellie. I'm sorry. That point right there is -2, -1. What's the biggest x value? What's the biggest x value?
3.
3. Does it hit everything in between -2 and 3? Does it go the whole way left and right? So how do I list that? How do I list? I can't list them individually because we said there's an infinite number of points. So how do I list something, Ava?
-2 and 3.
Okay, but that doesn't give us enough. It's the right idea, but how do we say it? So we basically, are the x values bigger than -2? And they're at the same time smaller than 3? This is where our compound inequalities come into play. I want all the numbers bigger than -2 at the same time less than 3. The way to write that, -2 is less than or equal to x, is less than or equal to 3. I got to use this when I got a line. If I just have points, I can list the points. All right, using that as a guide, the range or the y values. Do the same idea. What's the smallest y value? The smallest y value that you see. Jenna, what do you? -1. What's the biggest y value? 2. So if I go to -1, which would be right here in 2, does that graph cover everything in from between there? Yep. So it's going to be -1 is less than or equal to. Now instead of x, you need to use the y value. Domains are x's, ranges are y's. Domain and range. All right. All right. C just has points. C just has points, so we can list those individually. I think I just froze. All right. I want you to see what you come up with for C and D on your own. Here's a hint for C. Don't repeat numbers. If something appears twice, don't repeat it. Just put it down one time. Oh, that's for.
What do you guys think are the four are the domain points for C? What do we got? Yeah, Mason, what do you think?
-1, 1, -2, 2.
Okay, let's put them in order.
So
-2, right? That's the farthest what? X value to the left?
yeah,
Then what?
the -1,
-1, then what?
1,
Careful. Isn't there one at the origin?
or 0.
So it'd be 0, right?
Yeah, 0, 0.
Then what?
Then 1,
Then 1, then what?
then 2.
Then 2. You got it?
Yeah, good. So what did he list? -2, -2, -1, 0, 1, and 2. So all right. So if you look at those points, that would be the point -2, 4, -1, 2, 0, 0, 1, 2, 2, 4. So you just listed those x values. Now I did ask you for the range. I said don't list. You don't need to list it twice. Smallest to biggest. What do you think that would be, Mason?
024.
024. That's all you got to put. 024. Once a number appears in either one, you don't need to list it again. Is that a function? That function. Emily, any ideas?
Yeah.
Yep, you're all choked up. I know. Functions get me that way
It's
too.
emotional.
Yeah. It passes the vertical line test. Passes the vertical line test. It's okay that the ranges repeat. That's okay. You don't see any two domains. Now D, this is a continuous graph. You're going to have to use that less than or equal to notation. You cannot list individual points. So I want you to try the first time. Okay, I'd use pencil.
Range is gonna be tough.
I think they're both tough. Okay, but I just want to see what's kind of clicking in your head or what's not clicking. That helps me a little bit. So think about this domain. Domain are the X's. Okay, so I'm going to put a little X here in front of that.
I thought that was gonna be a parabola, or continuous.
What? Oh, the
Stops.
range?
Yeah,
Yeah,
no,
it
it stops.
Right. But they'll do that. Right. Domain are your X's. Now we can't list them all because there'd be infinite points, because you can do a point everywhere. All right. Diana, any ideas?
It would be 4 is less than or greater than x plus less than or greater than 1.
All right. Now you gotta watch that. You can't say less than or greater than. It has to
I
be.
meant equal to some.
So I'm gonna write this down. Don't write this down because we're gonna analyze it for us. So 4 is less than or equal to X is what?
Less than or greater than
Less than or equal to
4.
4. All right, now let's see where we're gonna. X's, you need to think left and right because you're thinking up and down. Here's what I think you're thinking. Furthest point on the left. Furthest point on the left is this one right here, which has the coordinates of 1, 4. Furthest point on the right is right here, which has the coordinates of 5, 4. Okay? So we want to go left to right. Now, what do you think? Now, that Diana's a little bit off here. I want to see what she was thinking from here. So, what can you come up with? Maya, what do you think? What's the furthest point on the left? The X value. What is the X value of that point?
1,
1. Just the X value, which is the first value. That is going to be the 1. That's going to go there. What is the X value of the furthest point on the right? Okay, that is going to be 5. So 1 is less than or equal to X is less than or equal to 5. We use the equal to part because they're solid dots. All right. So you think here, this is usually what I do, is I find the furthest point on the left and I go to my x-axis and I put a mark. And then I go to the furthest point on the right and I put a mark. And then that tells me it's 1 is less than or equal to x is less than or equal to 5. So I go left to right. Range is up to down, low to high. What's the lowest point? Lowest point on that graph. It is right there. 3, 0. And I go to my y-axis and I put a mark. What's the highest point? Highest point is right up here at 4, right? And it hits everything in between. So always start at your lowest point. 0 is less than or equal to y is less than or equal to 4. Okay? So 0 less than or equal to y is less than or equal to 4. Yeah, you gotta be careful of that. All right, so this, if it's trapped, if it has a high point and a low point, you have to do the same thing with your domain and range, which we did with B as well. All right. Okay. This is different. You need to get started so that we can help you. And we'll also get back your tests here once we get them recorded. Page 116, 1 through 40. Or 1 through 14. You can do 1 through 40.
1 through 40.
You can do 1 through 40 if you want. But 1 through 14.
Inventory of grades.
Yeah, let me stop this recording real quick.